So Toricel or temsirolimus for use in advanced renal cell carcinoma is prepared for infusion by adding 1.8 ml of special diluent to the drug vial, resulting in 3 ml of injection containing 10 mg per ml of the drug. The required quantity is then added to a 250 ml container of sodium chloride injection for infusion, and the recommended dose of temsirolimus is 25 mg infused over 30 to 60 minutes. The quantity of drug delivered in mg per ml and the rate of infusion in mils per minute for a 30-minute infusion are. So, okay, let's think about this. First, the way I would imagine this is what's really happening in the situation. So what they did is they added 1.8 ml of diluent to a drug vial. So the drug vial, if I'm just drawing it, resulting in 3 mLs. So this vial is a 3 ml vial, and it contains 10 mg per ml of your drug, right? Of the temsirolimus. And then the required quantity is then added to a 250 ml container. 250 ml of sodium chloride, and the recommended dose is 25 mg, but they infused it for 30 minutes, so that's what we're going to go by. Okay, so we're going to find the quantity of drug delivered in mg per ml and the rate of infusion in mils per minute. These are our unknowns and what we're going to solve for. This and this. So this 1.8 ml of special diluent that they wrote in the problem isn't really going to be used in this problem. Like, they kind of just wrote it there to trick you, but what you're really looking at in the big picture is you're going to take quantity from this vial and you're going to add it into the 250. So it doesn't matter that it's a 3 ml vial either. All that really matters here is that there's a concentration of 10 mg per ml in this little vial that we're taking out and pouring into the 250 ml. So your total volume in the end is going to change too, right? Because you're going to be adding so plus volume from vial. So what happens is, since our recommended dose is 25 mg, we need to measure out from the vial to give us the 25 mg. We need to measure out a volume that will contain 25 mg. So how do we get volume here? Well, we have something that has 10 mg per mil, so you put the 10 mg in the bottom to cancel out with the 25 mg, and this is just going to be left as 1. So if I measure out 2.5 mLs from that 3 ml vial that contain 10 mg per mil, this right here is going to contain our recommended dose of 25 milligrams. Will contain 25 milligrams. Okay, then it's asking us what was the quantity of drug delivered in mg per ml. So this is our first unknown that we're solving for. So we delivered 25 milligrams, and now we need to put it over a total volume. So this was 2.5 mLs. Added to the 250 mLs. And this is from that IV bag. So if you calculate this, it's going to give us 0.099 mg per mil. And then the second part of the problem. Okay, then for our second unknown, it's asking us to solve the rate of infusion. mLs per minute. So now we have to go based on this value that we solved in the first unknown. So I need to set it up such that I have milliliters in the numerator and minutes on the bottom. So what I'm going to do is I'm actually going to flip my answer from the first unknown, and I'm going to do 0.099 mgs on the bottom and mLs at the top. Then I know that I put 25 mgs into the solution, so that's going to cancel out with the mgs. And then I want to be left with minutes. So we have, I want to be left with milliliters. So it's asking for a 30-minute infusion rate. And if I do this, I'm going to be left with milliliters per minute. And if you do the calculation, your answer should be 8.42. Okay, so now we have solved for our two unknowns. For the first one, we're going to have 0.099 mg per milliliter. This is the quantity of drug delivered. And then our second unknown was the rate of infusion. And your rate of infusion should typically be in units of volume per time. Okay, that's it for this problem. If you guys have any other questions for this problem, just feel free to contact us. Thank you.